Okay, we're going to pick up where we left off in computing domain and range. So now looking at part C, we want to find all of the inputs that this function takes in. And again, you can think of that as like the shadow of this graph. And so I get -2 is contained in there because there's a closed point right there, and it projects down to x equals -2. And then all of the x values between -2 and 1 are included, but we don't include x equals 1 because there's a hole above it. Okay, let me clean the graph up a little bit, and we'll compute the range. So the range is all the outputs, and here you see y equals 5 is an output when x is -2. Y equals 1 is an output when x is 0. And some people get confused about what to do with this hole over here. When x is 1, y is almost 2, but there's a hole there, so you don't include it. But the point is that when x is -1, y is 2. So 2 is an output. It's not an output when x is 1, but it is an output when x is -1. Okay. So the point here is that the range is all values from 1, y equals 1, up to 5. And we always write the range in interval notation in increasing order. So you got to think of all the values from y equals 1 up to y equals 5. And we have one more example. That's D. Here the domain is all values less than x equals 4. So that would be -infinity to 4. Or you could also write that as x less than or equal to 4. Now the range is all y values greater than 0, because when x is 4, the y value is 0, and then the function just keeps increasing as x moves to the left towards -infinity. So the range is going to be 0 to infinity. And the reason we put an open bracket next to the infinity is not a finite point that we can include in the set. So you can't actually include that endpoint in this case.